All right. Okay, so now we are going to be looking at sketching hyperbola and finding equations of hyperbole. Okay. All right. So I want you to start off by doing question C, okay, and question D. It comes from page 14 of your upper 5 graph notes. Okay. Right. So try question C by yourself. Try question D by yourself. Okay. Right. Do C first. Press pause. Come check it. Right. So when you're drawing hyperbole, sorry about that. Okay, we've got g of x is equal to 3 over x minus 1. This is a function that I'm drawing. Well, the first thing, remember, hyperbole have two asymptotes. So always the first thing that you're going to draw, okay, is you're going to have to draw in the vertical. I'm making a video. Draw in, you can walk through that quietly. You draw in the vertical asymptote and you have to draw in the horizontal asymptote. So your vertical asymptote, okay, is going to be where the whole function is undefined, which in this case will be at x is equal to 0. So draw in your vertical asymptote. Okay. Then you're also going to need your horizontal asymptote, and your horizontal asymptote is always that number at the end. So it's 3 over x minus 1. So your horizontal asymptote is y is equal to -1. Okay. So draw in your asymptotes first and label them. The equation of that asymptote is y is equal to -1. The equation of that asymptote is aligned with the x coordinates are 0. Okay, remember, your graphs cannot cut the asymptotes. The asymptote river has crocodiles. Okay, once there's been a vertical shift, you are going to have an x-intercept. Okay, graph will cut the x-axis. So you have to go find the x-intercept. When a graph cuts the x-axis, okay, the y-coordinate is equal to 0. So you sub in the y coordinates of 0. So you've got graph G, which is the graph y is equal to 3 over x minus 1. Okay, so you're going to sub in y is equal to 0 into that function over there. Okay, and you get 0 is equal to 3 over x minus 1. How do I solve for x? Well, the first thing you need to do is move that minus 1 to the other side. So I get 1 is equal to 3 over x. To get that x to the top, you multiply both sides by x. And when I do that, times that side by x, times that side by x, I get x. Those x's on the right will cancel. So you get x is equal to 3. And what you've worked out is that when the x coordinate is 3, that goes with the y coordinate of 0. Right? So then you go plot that point. Here's the point 3, 0. Label it, even if you've done the working. Okay. And then show that the graph heads towards the asymptote. Heads towards the asymptote over there. Okay. The other half of the graph, well, if you don't even have to do anything, you just show it heads towards the asymptotes. But if you want, just pick any value to the left of 0. So let's say I picked x is equal to -3. If x was equal to -3 and I subbed it into that equation, we pick y is equal to 3 over -3 minus 1, which is -1 minus 1, which is -2. So you've worked out that when x is -3, y is equal to -2. So that point is over here, but you actually don't even have to label that. As long as you show, okay, that the graph heads towards the asymptotes. Okay, so there the graph is heading towards the asymptotes, right? So when we mark it, you've got your intercepts, we mark you've got your shapes, but we mark you've got your asymptotes, all correct. Okay, so that's that one over there. Right, if you haven't done it now, go press pause and try D by yourself, and then come look at solutions. Pointless just not trying it first by yourself. Okay, so your first step, okay, for the next one, okay, is you have to go figure out the asymptotes. So the asymptotes, well, because of that number on its own, first of all, it's going to be y is equal to 1. So go draw that in and label it. Y is equal to 1. Then I need a vertical asymptote, that's your horizontal asymptote. Your vertical asymptote is where the function's undefined. And for your purposes this year, your vertical asymptotes will always be at x is equal to 0. So label those asymptotes, that's always your first step. So there's been a vertical shift, and if there's been a vertical shift, then you are going to get an x-intercept. Cut the x-axis. How do I find that? Well, the function is y is equal to -2 over x plus 1. And we know that at an x-intercept, the y value is 0. So if we combine those two things, I get 0 is equal to negative 2 over x plus 1. Move that 1 to that side, or we can move the negative 2 over x to that side this time. So I get 2 over x is equal to 1. How do I get rid of that x at the bottom? I times both sides by x, so I end up with x is equal to 2. What have we worked out from this graph? When the y coordinate is 0, the x coordinate is equal to 2. So that is the point 2, 0 over there. Label it, show that your graph is heading towards, sorry, my curve is not very pretty, is heading towards the asymptotes. So that's getting closer to that line. Okay, you've got another half in the other quadrant opposite. Okay, so let's just pick, take the equation and I sub in x is equal to negative 2. You're going to get y is equal to negative 2, replace x with negative 2 plus 1. I get y is equal to 1 plus 1, which is 2. So this graph will also go through the point negative 2, 2, which is over there. Okay, but the most important thing is in this quadrant, you show that the graph is heading towards the asymptote. And that is the graph of G over B. Right, that's sketching hyperbola. Okay, the next thing we want to look at is this example over here. So you go to page 16 of your notes. Okay, don't know why it says collapse all there. Okay, so you go to page 16 of your notes. Okay, and we've got that function over there. Okay, it gives you the steps over here. Okay, you can read through those steps yourself. Okay, right. So read through those steps, follow those steps, go and try to find the equation of that hyperbola over there. Right, press pause, try to do it yourself. Okay, hopefully you've tried it yourself. Okay, so the first thing I look for, it says go look for the value of the horizontal asymptote. Well, the horizontal asymptote is over here. Okay, so what's the equation of that line? That line is a line y is equal to 3. So the general formula is y is equal to k over x plus b. We need the value for k and we need the value for b. Always find a value for anything which is not an x or a y. Okay. So in this case, well, the horizontal asymptote is the vertical shift, so that is p. Okay, so p must be 3. So the equation now becomes y is equal to k over x plus 3. Okay, I still need to find the value for k. So what's our technique then? Okay, we find a point that lies on the graph, which in this case is 2, 2. So I'm going to sub in 2, 2. And I get 2 is equal to k over 2 plus 3. Okay, move the 3 to the other side. So I get 2 minus 3 into negative 1 is equal to k over 2. Okay, times both sides by 2. And negative 2 is equal to k. Right, so now I go back here, stick that back into there. Okay, and my final answer then is y is equal to negative 2 over x plus 3. The name of the graph was G, so we should, to be fancy, say G of x is equal to negative 2 over x plus 3. Okay, and that is the equation of your y. Okay. Right. Okay, I want us to have a look at this one over here. Okay, it says you've got the function, okay, y is equal to 2 over x plus 1 is illustrated in the diagram above. Okay, now it says, first of all, okay, so they've given you the equation of this graph. Here's the graph, y is equal to 2 over x plus 1. Okay, the first thing you got to find is the equation of the asymptotes, okay, and draw them above. Well, the fact, what can't x be over here? Okay, x cannot be equal to 0, so you can draw in your vertical asymptote. There's x is equal to 0, okay, and that's moved up by 1. So your horizontal, that is going to be y is equal to 1 is your horizontal asymptote. So your equations are x is equal to 0 and y is equal to 1. Right, now what do we know about the axes of symmetry? Well, the two things to remember with the axes of symmetry in your notes about. First thing is they pass through the intersection of the asymptotes. So where is the intersection of the two asymptotes? It's over there. What's the coordinates of that point? Okay, yours are always going to be on the y-axis. Coordinates of that point are 0, 1. And there are two axes of symmetry, two fold lines where the graph will be perfect reflection. They'll always go through there. One will always have a gradient of -1, and the other will always have a gradient of 1. Okay, and that is going to be your key idea always for finding the equation of the axes of symmetry. Okay, they will go through the point of intersection of the two asymptotes. The one will have a gradient of -1, and the one will have a positive gradient. So if we call this one over here, line 1, the one with the negative gradient. Okay, so the negative gradient one, well, we're going to say y is equal to mx plus c. Okay, and we know two things straight away. We know that the gradient is -1. So y is equal to -1x, or just -x. And we know the y-intercept. You've always had know the okay. Your point of intersection of the asymptotes will always be the y-intercept. So the y is equal to -x, okay, and c, the y-intercept is 1. So that's your one axis of symmetry. Okay, this axis of symmetry over here. Well, here the gradient is 1. So if I use y is equal to mx plus c, you get y is equal to 1x plus c. Okay, and c is the y-intercept, which is at 1. So you end up with y is equal to x plus 1. So that is the equations of the axis of symmetry. The one will have a gradient of -1, one will have a gradient of 1, and they'll always go through the point of intersection of where the asymptotes meet. Right, that's hyperbole basics. Okay.